Hi, this is Naomi Andrag, and this video is on solving systems of equations by graphing. This is actually a question one of my students asked about, and it's a system of equations that was given to us. I've kind of inserted this information. It was just this equation and this equation. They're both in slope-intercept form, so I'd use the slope and the intercept to graph each of them. So part of that is just identifying the y-intercept. Part of it is just identifying the slope. So for this first one, we know that the y-intercept always has an x part of 0. And then if I substituted 0 into this equation, that part would go away because it would be 0. And then y would be negative 3. It's always just the constant number part that's added on there. What did I just do? That's not what I meant to do. So the y-intercept would be 0, negative 3 for this particular equation. And then when I graph it, it's over 0, down 3 right there on the coordinate plane. Now to get another point, I need to identify the slope. And here the slope, it's always just the coefficient of x. So here it's 2. And I can think of that as up 2 over 1. So that means that from this point, I'm going to go up to right 1 to get to the next point, up to right 1, up to right 1. Now, these graphs, sometimes they can be a little inexact, so I'd probably go as far as I could from this point. Let's see, up to right 1, up to right 1, it's right there, up to right 1, up to right 1, up to right 1, up to right 1. It looks like that's the last one that's going to be on my grid. So the graph of the line would look like this. It goes through this y-intercept, and then I could get several more points by going up to right 1 over and over again. And all these points are going to be solutions to this first equation, y equals 2x minus 3. And I could actually just take these numbers and sub them in. So this is 3, 3. If I put it into the equation, it should make it true. This point is 6, 9. If I put it into the equation, it should make the equation true. So that's the graph of this first equation given in slope-intercept form. Now the second one works almost exactly the same way. The y-intercept is going to be 0 something. It's going to be 0, 3, because that's the part that's added on, and also because if I put 0 in for x, that's what I'd get for y. So 0, 3 over on the grid, that is this point right here. Start at the origin, over 0, up 3. Next, I have to use the slope to get another point. Here the slope is just 1. There's no coefficient of x, but when I have just x, it's implied that there's 1x. So the slope is going to be 1, and that I could give that as up 1, right 1. So I could go up 1, right 1 to get to the next point, up 1, right 1. There's another point, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And then the last point looks like it's going to be right up there. But again, there are several points on this line. They should all be solutions to the equation. So if I substitute any of these points in, that last one looked a little bit off. Right there. Well, still can't get it perfect. Any of these points, 1, 4, or 2, 5, or 3, 6, any of these points on the second line should make this equation true. Now, there's only one point that's going to make both equations true, and it's going to be the one point that's on both lines. So in this case, it's this point right here. That's the one point that's on both lines, and that point is, looks like 6, 9. So here the solution to the system of equations is 6, 9. And if I wanted to check that, I can just put it into both equations. So I would ask myself, well, is 9 going to equal 2 times 6 minus 3? Well, that's 12 minus 3. 12 minus 3 is 9, so that's right. And then it also should make the second equation true. So if I replace y with 9, is 9 going to equal 6 plus 3? Well, yes, it makes that equation true as well. So since it makes both equations true, it's a solution to both equations, and it's the solution to the system of equations. I hope this helps. Bye.